Now that we know what a binomial experiment is, we want to be able to find the probabilities for those binomial experiments. And the nice thing about a binomial probability experiment is that the formula, or there are actually formulas to find the probabilities. Instead of making tree diagrams and trying to figure it all out by hand like we did in Chapter 5 and Section 6.1, instead of doing all that work, there's a computer or calculator program that will just figure it out for you based off of a formula, which is awesome because that means that as long as you have a calculator, you can find all these answers. Now notice that there is a table right here that has what to type into the calculator over here on the right, and you're going to use this. It's also on your formula sheet for your exams, so you don't have to memorize any of this, you just have to be able to use it. Alright, so let's look down here. When we look up, let's start at the beginning. So n is the fixed number of trials, p is the probability of success, and x is the number of successes. Okay? Okay, so if we go down here, if I look at this problem, it says that I want n to be equal to 20, I want p to be equal to 0.6, and x equals 8. So I look back up at the table, I notice that the equal sign is that first row. So I'm going to be using this function over here, binom PDF. And I'm going to put in n, which for me is 20. And then I'm going to put in p, which for me is 0.6. And I'm going to put in 8, because that's my x value. So it's going to go 20, comma, 0.6, comma, 8 for me. Now let me go grab a calculator. And I'm going to make the screen bigger if I can. 1 second. There we go. Just so you can see it. There. So you get to the, you have to go to the distribution menu, which is above the variables key over here. So you hit second, distribution, and you want to find binom PDF. P stands for probability, and then D is distribution, F is function. So binom probability distribution function. So it's letter A. So I'm going to select that. It's going to ask me, how many trials do you have? Well, that's my n value, which for me is 20. So I type in 20. My probability of success was 0.6. That's my p. The x value I'm interested in is 8. So I'm going to type in 8 and go down to paste and press enter. Now this is unlike what we did in Chapter 3 and 4 when you would run one variable statistics or linear regression. At the bottom it would say paste, it would say calculate, because it would actually run the calculation. Here I'm pasting it into the calculator home screen, but it hasn't done anything with it, and that's because you can sometimes manipulate these values and do other things to them. So it's just pasting them in. If you want to run it, you have to press enter. And there it is, 0.0355. Call it. Alright, so I've got that one done. Now let's look at letter B. Letter B wants the probability that x is less than or equal to 10. So that's row number 3, right? So, and if you want, you can make a little note to yourself. You used number 1 on this one. So for the next one, we're going to use row number 3, and that's going to mean binom CDF. CDF stands for cumulative distribution function. And you might notice that 2 through 5 all use CDF. The only time we ever use PDF is if it's exactly a number, exactly 8, like in our letter A. But all the rest of them are going to use CDFs, so cumulative distribution. What that means is the calculator finds the probabilities for 0, 1, 2, 3, and so on up until x, and it adds them all up for you. So we're going to type binom CDF. So let me go back to my distribution menu. So second, distribution, and it's going to be letter B. You can get to it with the arrow keys if you want, and press binom CDF. It wants to know the number of trials, which is still 20. It wants to know the probability of success, which is still 0.6. And it wants my x value. I'm going to type 10 and press paste, enter. Enter. And that gives me 0.2447. Now you'll notice that I actually used the 10 as my value, because it tells me in row 3 if you're doing less than or equal to, you stop at the value you were given. We were given 10, so we're going to stop at 10. And the calculator knew that by us putting in that 10 there, it's saying, look, I'm going to add up the probability of 0, 1, 2, 3, 4, and I will add all those values up for you, and I will stop at 10, which is what we wanted because of the or equal to part. That's the key to this one, that extra little or horizontal bar right there. Unlike letter C, so B and C are good ones to compare. Letter C says, I want you to be less than 12. But what that means is I want 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And stop at 11 because 11 is less than 12. So I'm not going to go all the way up to 12. And you can see that in the rule. It's number 2. It says to go to x minus 1, which in our case is 12 take away 1, which is 11. That's where it'll get it to stop. So I'm going to use binom CDF. So binom CDF. And since I've already typed this in, the stuff is still sitting there, but I'm going to tell it to go to 11 this time. Much like this is Spinal Tap. Go to 11. And there you go, 0.4044. And I just typed that up, and I wrote a little note to myself of which one I was using, because I was using number 2 there. Okay, now for D, I want to be greater than 15. So if you look at the list, greater than 15 is rule number 4. So I want to do 1 minus binom CDF. Because, of course, all the binomial probabilities for this experiment add up to 1. So what I'm doing is I'm saying, hey, calculator, add up to 15, but then take it away from 1, and I'll know what 15, 16, 17, and so on added up to. Sorry, I mean 16, 17, 18, and so on. So it's going to add up to 15, and then take away from 1 will get me all the rest. Right? So what you really want is the probability of 16 through 20. So what you tell the calculator to do is find through 0 through 15, and you know that by the fact that it stops at 15 right there. So it's going to add up probability of 0, probability of 1, probability of 2, and all so on, all the way up to 15, and include 15. But then when I take it away from 1, I'll have all the rest that I didn't know, right? So 16 through 20 actually only adds up to 0.0510. And I can see that because I can type it in. 1 minus distribution menu, binom CDF, 20.6, but then type 15. And that's why you paste right there, so that you can put 1 minus or something similar to that and have the computer or the calculator run the full calculation. So there you go, 0.0510, because the 9 gets rounded up due to the 5 after it. And there we have it. Okay, now what, and just for the record, this was rule number 4 that we were using. So number 4. That was the rule. All right, now for the last one, not the last one, the last row. Let's see, the probability of at most 12. Well, there's some words in that one rather than just straight up symbols like all the other 4 had. So we're going to have to go up here and look for at most, at most. At most is rule number 3 again, right? It means 0, 1, 2, 3, up to and including the value you're given. So that's going to be a straight binom CDF. So it's going to be a little bit like letter B. At most 10 was letter B. I didn't write it out in words, but that's what it was. So now I want at most 12. So what I want is for the calculator to find everything up to and including 12, from 0 all the way up to 12. So the way I'll do that is binom CDF with 12. So let me go grab a calculator. So by the way, once you've typed these in once or twice, you can go up with your arrows and go grab the value you're interested in, or the entry you're interested in. And I can just over type and type it with a 12. And I get 0.5841. So this would be 0.5841. Like that. All right, so that was an extra one of rule number 3. What about at least 15? Well, at least 15 is rule number 5. There it is. So this is the most complicated one because it's at least 15, meaning you want it to be 15 or higher. So it's not the same thing as letter D. I left those in there near each other for you to be able to compare. So it's greater than or equal to 15, which means it's 15 comma 16, right? And what that means is I'm going to have to add up to 14 and take it away from 1. It's not the same question as what I did earlier. So let me just go grab this because I'm curious to know the value. So I'm going to type binom CDF and make it stop at 14. And I get 0.8744. So this is 1 minus 0.8744. So I go back to the calculator. 1 minus second answer. It's above your negative sign. Press enter and you get 0.1256. So that's rule number 5 that we're using there. But I left letter D and letter F very similar to each other on purpose because I wanted you to see the difference between those two. That letter D, excuse me, I'm typing wrong. Letter D is greater than 15. So that means I stop the adding at 15 and I subtract from 1. Letter F is at least 15, which means I want greater than or equal to 15. So I have to stop the adding at 14, take it away from 1, and I'll know what 15 through 20 added up to. So these two are two that students often confuse with each other, letter D and letter F. So make sure that you pay close attention to those and look at the language. And if you look here in the table, it's written for you. I tell you for this last one, at least 15, don't use 15, use x minus 1, use 14 right there in the binom CDF. That's why I'm using 14 right there. And all of this is written out in this next table in case you're interested, how to use the calculator and such. But we've kind of seen that as we went through the problem.